Students, today we are solving ISI M.MATH 2021 subjective paper, and this is from a group theory question. They have given that let G be a group having exactly 3 subgroups. Prove that G is a cyclic of order p square for some prime p. So G has 3 subgroups. Okay, 1 G and some plus and some subgroup of H. So the group G has an element, if we take it as small g, such that G not equal to 1. So now if we take a cyclic subgroup S of G generated by G. So now in this subgroup particularly coincides with G, and thus G is a cyclic structure. So otherwise S of G equal to H, and there is an element H if we take, which does not belong to this subgroup. So let S of H be a cyclic subgroup generated by H. So hence S of H not equal to 1 and S of H not equal to S of G not equal to H. So then S of H equal to G, and G is cyclic. Okay, so the subgroup H has no proper subgroups. So this is actually order of the prime. So H equal to P, correspondingly G equal to Pn. For some integer n maybe we can take. So find the fundamental theorem of cyclic subgroups, so that if K divides n, so G has a subgroup of order K. So it follows this is only possible if the divisor n is P. So mod G equal to P square. That's it, proved.